Good morning all. I am Dr. Gayathri NS, working as Assistant Professor of Chemistry in SNS College of Engineering. Today we are going to see about electrochemistry, the part 3 video, that is about effect of dilution, EMF series, etc. Let's move on to the topic. In previous videos we have seen what are the conductance, non-conductance and types of conductance, etc. Today we are going to see about the effect of dilution, how the dilution affects the conductance. Generally, conductance depends on three factors. Many other problems occur, but the major factor for the conductance dependence is these three. There are number of ions, charge of ions and mobility of ions. These three factors plays an important role for the conductance. The number of ions, charge of ions and mobility of ions. As the dilution increases more, the electrolyte ionizes more and the specific conductance decreases, and the molar and equivalent conductance increases with the dilution increases, but the specific conductance alone decreases while dilution increases. Effect of dilution, we are seeing that the conductance depends on these three factors, that is number of ions, charge of ions and mobility of ions. As the dilution increases, only the specific conductance decreases, but other conductance of equivalent and molar conductance increases with the increase of dilution. And next we move on to the electromotive force, which is shortly called as EMF. Electromotive force is the difference of potential which causes the current flow from one end to another end. The first end is higher potential to the lower potential. When the current flow from higher potential to lower potential, the potential difference occurs. That is called as EMF. That is, EMF is the difference of potential. The difference of the potential which causes the current flow from one end to another end, that is higher potential to lower potential. That is E cell equal to E right minus left. E right minus left. We have taken the cathode is copper, that is in the right side, and anode it is in the left side, that is zinc. Here, for example, E right is cathode, that is copper, E left is zinc, that is minus E zinc, the EMF of the zinc. And these right minus left is overall it is called as EMF of the cell, that is E cell. Right hand side, E right is the reduction potential of right hand side and E left is reduction potential of the left hand side of electrode, that is EMF. Application of EMF. The EMF, the potentiometric titrations can be carried out. While in the potentiometric titration we are calculating the EMF. The potential difference is calculated through potentiometer. In that we are calculating the EMF difference only, so that we can know the concentration of the ions present in the solution. The EMF measurement is used for calculating how much ion is transferred to the solution, so that we can calculate the concentration of the solution what we have taken. Okay. The transport number of ions can also be determined using EMF measurement. While using the EMF measurement, how much ions, how the number of ions is transported from one end to another end, it can be calculated, and the pH of the solution can be determined. While the pH is an important factor in the water or sample any other solution, the pH plays a major role for what are the reaction we have taken, and the pH can be measured through this EMF measurement. It is very much beneficial to the titrations and the sample we have taken. It is very beneficial to calculate the pH of the solution. And the hydrolysis constant can also be determined using the EMF measurement. And the solubility of the sparingly soluble salt can also be found. We can easily predict the solubility of soluble salts. And non-soluble salt, it is no solubility, so that we can calculate easily. And soluble salt, completely miscible salt, we can easily calculate. But in the case of sparingly soluble salt, we cannot easily determine the solubility function. It is very beneficial that is by EMF measurement, the solubility of sparingly soluble salt like silver nitrate, we can calculate the solubility functions of these salts can also be found using this EMF measurement. This is the main application of EMF measurement. Thank you all.